I'm also sending a second pulse width modulator out this direction for you guys to look at. This one will charge one battery bank. That one will carry 2 of the 60 cell panels that are about this tall and this wide. Those are what they call a 24 volt panel. These will also work with 12 volts panels. Those are usually about waist high and about that wide. There's 36 squares in there, 36 cells. And so those, they call them 12 volt panels. If you look on the back, they may say 21 volt or 17 volts as the maximum open circuit voltage. That's not the operating voltage. What that is if you laid it out in the sun and there's nothing connected to it, the voltage pressure builds up. And so, but when it starts flowing, it's like opening a valve, the pressure drops. So the voltage comes down to what the operating is. This one's
Do we
kind
want to
of
have a formal opening?
This one will charge 2 separate battery banks. You can, if you look on it, you can have the setting for the switches to set it to charge 50-50 or 90-10. So if you have 2 things you're operating, say you have kids in the house and you don't want them to use the electricity for the refrigerator, you want to put the refrigerator on a separate battery bank and then connect the Xbox to the other battery bank. And when they run out of juice, they're not going to kill the refrigerator.
And Eddie, again, if you want to actually have that shown on camera, you have to be...
Like I said, I'm just kind of explaining what I'm passing around, and then we'll wait for the questions.
Gotcha.
Do we want to start then?
I'll give it a couple more minutes. What time is it?
Okay. Wait,
I mean, actually, Bill is not, he's at a city council meeting. He's gonna come.
But we don't have to wait for Bill.
No, but
So just let me know.
usually people don't really get here till 6:15. It's terrible. Is this the whole charge controller right
That's a
here?
whole charge controller. It's small.
The small, yeah.
Yeah. It will handle one of the big panels by itself. Okay. But if you wanted 10 big panels, you could have 10 charge controllers all going to the same battery bank. So you can stack them, is what it's called.
They can talk to each other and know.
They know
what charges are coming
so
in.
they're pulse width modulators. I guess we're ready to start, guys. We're getting questions.
How much does this cost?
That one's $86 with the remote controller. So you can put this in the house. I think this cord is 50 feet long, 50 feet away from the solar, and you'll know how much voltage you have. You'll know how much power is coming in from the solar panels. All of that's on a little LED screen here. I'll pass that around also.
How much did you say?
did anybody
I think it was
introduce-
$86 wholesale.
Anybody introduce our guest speaker?
Not yet. No.
Okay. I'd like to do that.
Okay.
Okay. Well, we're very privileged and very happy to have Ed Munoz with us this evening, and we know that he is an encyclopedia full of information, knowledge, and experience to help us understand solar. So we are really grateful that you took the time, Ed, to come and be with us, and appreciate very much that you're sharing all of your experience and knowledge with us. And the theme this evening is...
Batteries and charge controllers.
Very good. Very
Okay. So somebody want to grab this one so I can stay in the camera range, because I'm going to start pointing, and that's the remote control. You can turn the charge controller on or off, but you can check your battery voltage, your amperage that's in the batteries. It tells you how much is coming in from the sun. Kind of a nice little meter to have. It adds about $15 to the cost. Okay, those are pulse width modulators, and you'll see them when you're advertising. If you go to buy a charge controller for from Amazon, it's going to be a PWM or an MPPT, one of the 2 types of charge controllers. The great thing about these is they're low cost and they're durable. They don't have any real moving parts in them, so I mean they last pretty good. Sometimes they get damage from water. If sometimes people will put them in like a place where they overheat, and you'll notice they have louvers on the backs of them and stuff of the charge controllers. That's to keep the temperature down and keep the efficiency up. So temperature is definitely a adversary of your lifespan of your charge controller. So the pulse width modulator, it charges in pulses. That's why it's called a pulse width. When the battery is really low, when it's down at its lowest charge point, it's just pushing in a straight line. Everything that's coming from the solar panel is flowing just like if you open the valve all the way on a water line. Everything that can come from the solar panels is going straight into the battery. Now you can hook a solar panel directly onto the battery, but here's the problem: is as it fills up, it will overcharge the battery, and it doesn't stop. That's what the charge controller does. It protects the battery from overcharging or from charging too fast. We've all seen chargers that we buy now, and they slow down as the battery gets fuller, right? Anybody see that one? All right, that's a pulse width modulator in a regular old battery charger. What it does is as it fills up, you'll see I have a series of short dashes. Well, if these open spots are when there's no power flowing. So it's still giving the full voltage of the panel, but just in pulses, okay? And if, or the line is really off and then the power's flowing when it's on, what happens is as it gets fuller, it's off longer, and it's so the pulses are short bursts and they're farther apart, so it lets the battery kind of chill down if it flows it in real slow. Okay, that's the good thing about a pulse width modulator. Like I say, is you can find them on Amazon for $8 and $10 for a single panel. If you're just going to charge a battery and you want lights in your house, really low cost. You can get started that way. Your panels, as long as you stay with good quality panels, and say if you're going to go with the 12 volt, go with the 100 watt. You might want to write that one down if you're going to start small. Go with a 100 watt panel. You can buy 100 watt panels anywhere. I'll give them a little bit of a brief and in a minute on where we're going. I'll try to catch you up. We're going over charge controllers. Okay. This is a pulse width modulation charge controller, PWM. It's written right there. You look on the bottom of the charge controller, it's pretty easy to hook up. On the front, it has pictures where all the wires go. So you can see your solar panels go in. The positive wire goes into the positive connection that has the picture of the sun on it. You put the negative into the negative side. Pretty simple to hook up. Then the battery's the same way. It's just like hooking up a set of battery cables. You saw on the single battery side where it only charged one battery, that it had a positive and negative. Those leads just screw in on a good sized piece of wire depending on how big the panel is, how far away it is also from the charge controller of the battery can also change your wire thickness. So the shorter the distances between batteries, chargers, and a solar panel means that you get to use smaller wire because you're going shorter distances. If you were to take a solar panel and put it 100 yards across the field, you'd be running on wire this big, no joke, just to get the power through there efficiently and not have line losses and not overheat the wire when you start pulling too much. So, keeping your distances short is really good. So on the pulse width modulators, I was showing them that when the batteries are low, it opens up and lets every bit of electricity that the panel's making flow straight in. It doesn't stop it. As it fills up, just like on a charger that you buy, a good quality battery charger, as it slows down towards the top, it's on for shorter periods of time and it's off. This would be the shortening of the span, and as it fills up, it's off more than it's on, so the line increases. It keeps the battery from overcharging because it has a chip built into it that as it fills up, it just slows it down. It protects the battery. Once it's full all the way, it shuts off. Okay. The pulse width is, like I was telling these other people, they're low cost. They don't break down. You see, they're really simple. They last a long time, but they are 30% less efficient than the pulse width modulator. I'm going to start passing 2 pulse width modulators. The MPPTs. Now I'm going to pass up the max PowerPoint tracking. You caught me. I was talking and not thinking. So this one will run either 12 or 24 volt panels. This one will run 12 or 24 volt panels. This one will charge a 24 volt battery bank. This one will only charge a 12 volt battery bank. Okay. This one, you'll notice that it will only carry 1 of the full size panels. This one will carry 2, and we'll go over some of that stuff as we go along. This one about $189. This one's about $399. This is the lower. These are the lower ends of the MPPT, the smallest you can get. The next step up is about $500. There's a couple of really good companies. Outback is always good equipment. It's simple to install. It has a good data recording system on it, so you can see exactly how your solar panels are performing, how your charge controller is performing. You'll know the high and the low of your battery every day, and it keeps 180 days of data on record. So for $585, $600, the Outback definitely has all the bells and whistles. For about $70 less, you can buy some other MPPTs. Morningstar is a really good brand. They're about $100 left. They have no reporting on it. What I find is the people that have the data have fewer problems, run out of electricity less times than people that don't have access to the data, because it's like not having a gas gauge and not knowing how full your tank is all the time. So, those are things you'll have to weigh if you want to spend the extra $100. If you don't, if you're going with 1 solar panel, $180. You can keep a meter, just an electric meter like you work on your car with around the house, and you can test your voltages and keep a little log of where you're at in the morning, where you're at the end of the day after full sun, and try to keep, you can record that data yourself, or if you buy the Outback charge controller, it's all there. So here we go. The first one is the 12 volt. The second one is the 12 or 24 volt. You can look, I didn't take the cover off of this one, but the leads are real simple to hook up on all of them. You can look at the other one, the diagram's already on it. So the MPPT, you see, instead of working as a set of pulses, it has a computer algorithm built into it that has a coil that's smoothing out the way the power is flowing. And it constantly adjusts this knee of the curve. And the knee of the curve right here that you see, that maximizes the amount of wattage, actual wattage going into the battery. So it gives you 30% more power out of the same solar panel. And if you have a big system and you're not running on MPPT, you are losing a lot of money because it's not recoverable. The cost is not that much more when you're able to start putting 1 big charge controller versus 10 small charge controllers on. Okay, all of the ones that we're passing around are stackable. So the biggest one you have that we're passing around can only hold 2 panels. A 80 watt Outback can carry up to 9 panels, 260 watts. And that's stackable, so if I wanted to put 27 panels, I would need 3 Outback charge controllers. and I could operate that also with it. So both of them are the pulse width modulators. You can get it in all three voltages, the 12, the 28, and the 40 volt, the 48. 12 volt, simple to hook up. I mean, anytime you go with 12 volt stuff, you're just like hooking up your car. Everything's marked on most of the good stuff. If you buy Morningstar, it has pictures where your wire needs to go, and it's pretty simple. Outback is real simple. They're diagrams. There's just a few wires to them. There's just a positive and negative coming in from the solar, and a positive and negative going out to the batteries. Those are the only two connections. However, everything, your panels, your charge controllers, everything needs to be grounded when you're working with electricity if you're going to hook it up yourself. All of this stuff available on Amazon, pretty reasonable, okay? You can save a little bit of money by looking a little deeper at some of the wholesale companies. Maybe they'll sell to you, maybe they won't. Maybe most of the time you're always going to pay the retail price. There's not much of a discount anywhere on solar, unless you're buying large quantities. Now, the difference in the price of panels right now, if I buy one panel from Amazon, I'm going to pay $400 for a 24 volt 250 watt panel. That's about $1.20 a watt plus shipping. If you're buying a whole pallet load, there's places that you can buy it now for 57 cents a watt. So the panels are now around $140 if you're able to buy a full pallet. They're about 140 each. Okay, lower the cost. Let's go over the pulse width modulator, the 12 volt and 24 volt. The two bigger ones would definitely cover both sides of it. How many of you know how to hook up a 24 volt battery system? Anybody here ever done that or understand that? Okay, so let's pay real close attention. What you're doing when you're hooking up two 12 volt batteries to get 24 volts, all you're doing is you're making one battery out of two, okay? So you connect the positive and the negative between the two batteries. You now have one battery technically, okay? You can get a picture of this with your cell phone or draw it out. At that point then just one lead goes to the negative side of the inverter, and one lead is left, which is the hot on the other battery, because you used one of each and you have one of each left, and that one will go. Real important when you're hooking up an inverter, not to cross the wires. There's some of them, they have protection built into them. Usually they'll advertise reverse polarity protection on the inverter, because you just tap it one time and you tap the poles the wrong direction and you can fry an inverter. Some of them. Ames, I see more of those out there. They're low cost inverters. They're available at 2 or 3 places. I see those, they last a long time on the reservation. And there's some old ones out there. And when you pick up an Ames inverter versus you pick up one of the little Chinese made inverters, it would take 4 of those inverters to weigh what the Ames, the same size, weighs. It has that much more copper in the system, and so it's easier on it. It runs a little longer. The little computer fans, they'll go out occasionally if you keep an eye on them and change them. They'll last a long time, keep them clean. They're low cost inverter supply. You can get those at Amazon. They're no more expensive at Amazon than they are at the places that say they're wholesale. I mean, wholesale, I have to buy 5 at a time to get the price down. It's not like, okay, if I go to wholesale solar and I buy one Ames inverter, I pay retail, even though I'm an installer. They'll give you guys the same price. You'll find Amazon is a great source for this stuff. Always draw and plan your electrical stuff out. Take a paper and pen. Use a red pen for your hot wire. Use a black pen for your negative wire. Draw out your picture. You don't get confused. Put pluses and minuses on things, because it's simple if you just keep it organized. and if you know where you're going with it. The other trick is buy red cable and buy black cable, so then you know where you're putting it. If you're gonna hook up your own solar at home on an off-grid, it's real simple to keep it sorted out. If you make your hot wires red and your other wires black or white, whatever you want to use, make sure that you don't get confused later. I had one rack of 27 panels, or it was a total of 3 racks of 27 panels that someone had installed in Ranchos near Albuquerque. The technicians, when they pulled the wire from the panels to the charge controller, they forgot to mark the hots and the neutrals. Okay, so I have 12 pair of wires and no idea which one's hot, which one's neutral, which one goes to which group of panels. Mark everything. If you have a label maker, put labels on it. It pays off. You may have to interrupt something, or something might happen. I've had people back into their solar racks when they had NFL parties and have to rewire that stuff. If it's not marked, it's expensive and time-consuming to trace it out. So mark all your wires. It simplifies everything. You'll notice on the charge controller, everything's clearly marked. So if you just stick with a couple of simple rules, it's really simple. It's easier. I would have a harder time hooking up an Xbox than your kid does. Because it's really simple. It's just a few wires. Keep them separate. If you're working with your panels, cover them up with a sheet of cardboard, throw a couple of blankets over them. I mean, I work on them hot all the time, but I also work on high voltage electricity all the time. If you know the rules and you play by the rules, and you're careful, you can work that way. But I mean, protect yourself. It is electricity. So we see how the 24 volt goes, and if you wanted to have 8 batteries on a 24 volt, then you would just tie each one of the groups together, and then you would bring in all 8 cables and try those all together, bolt them all together with a brass bolt. Put the gel that they use on the inside of the spark plugs caps and smear that on them, coat them, wrap them up good with tape, and then you can put 6 24 volt batteries together. Just always think, this isn't 2 12 volts, this is a 24 volt battery at this point. So you can put as many as you can as a group. You want to keep all the cables the same length, so that the electrons run evenly and everything balances out. 48 is pretty much the same thing. What happens if you want to connect a 48 volt, and there's a lot of reasons that you want to go 48 volt on your inverter and your battery bank, and we'll go over those. It's the same thing. In between the batteries, you're just connecting that one to that one and that one to that one. So each one of these now, this is all one battery. They're tied together here, positive to negative. This actually is now one 48 volt battery. If you look inside the cells, you're doing the same thing all the way through the cells, all the way through the batteries. You're now at 48 volts. Reason to go with 48 volts. The wire size is going to be 1/4 the diameter of the 12 volt if you're going to run a big system. Okay, you're running 4 times as much electricity on the same amount of wire, and the resistance hasn't gotten to a point where it's going to start heating up the wire. Voltage is pressure, so if I had a little rubber air conditioner tube and it was just dripping, I'm not going to be able to get much power through it. But if I turn the pressure up to 900 pounds, it's going to be like a jet that'll cut rock, and the water's flowing out of there. So that's voltage is pressure. I always refer to voltage, as pressure. So if you were to put another group of 48, you would do the same thing, and then you would tie the positives and the negatives of the group together. Then you would take the group, so this would be the second battery bank down here, and so I bolted these 2 groups together. Now I take a wire to the negative on the the inverter and a wire to the positive on the inverter. And that's the whole storage side of it. The plugging in of the panels into the charge controller, you do have to pay attention to how you plug them in. There's 12, we'll erase this in just a little bit. We'll let you guys ask some questions. Then we're gonna go over how to hook up the solar panels to get the desired voltage out of the panels. So anybody have any questions on battery banks?
How many sets of batteries could you do on the 24 volt?
So they normally say four groups on a bank. So what I could do is I could have 4 groups of 4 tied together this way.
4 groups?
And then I could have another set of 4 groups of 4, and that groups would tie to this group in a direct connection. So if I wanted, so if I had, you don't want more than 4 batteries running to the main, what they would call a shunt. A shunt is a piece of metal normally that has holes drilled in it that you start bolting cables up to. So you could bolt it up to what would be a shunt. Look. I have one more over here. So, let me find the first one. A shunt would just be a block of metal with holes drilled in it. So, if my cable coming to the inverter, and then this would be the cable going to these would all be plus. Okay, this would be a block of metal, and then my charge controller, connections. This goes to the plus on the charge controller. This goes to the plus on the inverter. This one goes to the plus on the battery, and then another battery bank on the plus side can come in and bolt onto that one plate. Now, you can do the same thing by bolting them all together. If you keep all your cables equal, the batteries tend to balance out better. It's kind of like believe it or not, electrons are have a lot in common with water. And so if you filled a tank with water and you started sloshing back and forth, you could see the one tank would start, if one got higher, it would start flowing to the other tank. It's the same thing with a battery. If your cables are shorter, the load is going to go into those batteries and fill them up. It's going to slowly fill the other batteries up because they're uphill from it. So if the cables are all equal, then all the batteries are going to fill up equal. So that's what the target is on it. Okay.
Well, I have a question. This NPPT, I mean, I already know that knee, you know, that ratio between, what is it, voltage and amperage?
Right.
Is what the NPPT is calculating.
Right.
And that's what makes it different from the pulse. The
Yeah,
pulse is
because-
just as simple. It doesn't really get as much power out
Well-
of the panel.
Right. And so,
But don't go too far into it, because I
no,
know it's really
that's kind of
complex.
a tough question that takes quite a bit of math to explain.
But just,
Let's look at it. This would be sunrise. So the voltage would go up all the way, but the amperage would be really low. Okay?
in the beginning.
In the beginning, because the sun's not strong enough. Okay? The voltage can get there, but you're not producing many amps, so there's not many watts being. So the knee would be, at say 8 o'clock in the morning, might look something like this. Okay? So the amperage is very low, but the voltage is almost at full voltage. And so it doesn't take much for the panels to get to full voltage. You can put a panel in a building that's well lit, and you can get full voltage out of a 12 volt panel. You can get 21 volts out of it sometimes. There's hardly any amps. I mean, you could stick the electrodes on the side of your head, and it might tingle a little bit, but hardly any.
But you're saying that the reason that you spend much more on the MPPT is that it has this other calculating
It's
ability.
constantly, this knee is changing.
It's
Every time the cloud goes over, it's adjusting the amperage to the wattage to maximize, or the amperage to the voltage, and the maximum amount of wattage is going into storage. So it's more efficient at harvesting the electrons in a changing environment, because the pulse, it's changing all the time. So that means that sometimes it's a low amperage pulse, it's still at full voltage, then it's a full amperage pulse as the sun changes constantly. If a bird flies by one corner, there's a change. This can keep that knee there to where there's a maximum amount of wattage going into it.
Good enough for me.
What exactly does MPPT stand for?
Max power point tracking.
I have another question.
Okay.
You never mentioned 6-volt batteries and going up to 12 and having a 12-volt system?
Well,
Is
we
that
can-
just too small?
No, I'm still replacing the old wet batteries, pretty frequently.
Oh,
They're still the workhorse of the industry. The 6-volt batteries she's referring to are golf cart batteries. You got an eraser here?
a rag. I'll get it.
Yeah. And so you can get 48 volts. You can get whatever voltage you want out of a battery, out of a 6-volt or out of a 2-volt battery, because the fact remains that a Tesla runs on 6,000 small lithium-ion batteries. That's it. And so it's getting high voltage. It's the way you hook it up. It's the same with the panels. Getting the correct voltage operating voltage for the solar panels. Give that a minute to dry. Start over here. So there's series and parallel connections. If I hook my pluses to the pluses and the minuses to the minus, the voltage stays the same, but the number of amps increases, okay? If these are 100 amp hour batteries and I hook them up parallel, which is the positive to the negative to the negative, and then my inverter goes right here on the negative and the positive on the inverter. If I can chain, you shouldn't chain more than 4 batteries in a chain. And there's reasons for it in physics. It's actually the thickness of the lead applied each time, because you're talking resistance. Because the electrons on this one, they actually come in on the negative side charged. They become more negative. And so they have to go all the way through here to be recycled. And so that's the thickness of the lead plates of 4. And so they tell you not to put, there's the reason for not putting 4 batteries is you start getting into areas of resistance on the thickness of the amount of metal you're going through. So if you had 4 and 4, it changes, because the electron's only going through 4. It's not going through 8 batteries. They're all going to the shunt or to the same spot. The same thing when they're coming in, because when I'm charging from the charge controller side going to the batteries, as those electrons are flowing into the battery, when they hit the shunt, you want to hook it, if you're doing multiple battery banks, when they hit the shunt, they're going to equally distribute. It's like a bunch of water tanks or baffles in a tank. They tend to level out. The pressure, unless you have a bad battery in there, then things change. But so now we're talking about 6-volt batteries. Almost try. So for each 6, you're going to have a positive and a negative, and these are each 6-volt batteries. Okay, So if I go from positive to negative, I've made two 6-volt batteries, and now this is a 12-volt battery. Now if I take the positive and the negative again, and this one's hooked together, so this is 12 and 6, so 18, 24, 36, and now I'm at 48. So I still have a positive to go to the inverter and a negative to go to the inverter. And also the charge controller, the electrons are going to use the same path of wire. So you can turn a bank of 6 volts into a 48 or a bank of 12s. You mostly see on the 6 volts, people building 24 volt systems. There again, if you stay at the 24 volt level, then you're passing the electrons through 5 thicknesses of the batteries that they have to travel through. So 24 volt on 6 volt batteries is more common, and it does make more sense just from the standpoint of design. If you're going to do a 48 volt system, you're better off doing this. There is another way of doing it. You could do 4 banks of 4 that are connected in series, and then they go to parallel. So it can get really complicated to do some of this stuff. And in big battery banks, it has to be done. The Vermejo Park has over 600 of the semi-sized 12-volt batteries in their battery bank to operate their lodge. And
How many batteries?
they have 600 batteries.
600.
Yeah, and so that actually is operated through a series of shunts, and it's groups of 24 that add up to sets of 48. And actually, in some points, it's kicked all the way up to 500 volts, because there's a lot of motors that industrial motors, like for pumps and things like that operate at 500 volts. Well pumps, some of them operate at 500 volts, and you can develop that belt voltage through setting up batteries in specific ways. The same with the smaller voltages. It's the number of batteries connected in series. So in parallel, your amperage adds. In series, your voltage adds. So 6, 12, 24, 36, 48 volts. Okay. There's a bank of 4. But like I say, you could split it into 6, 12, 18, 24, and then do another group, and then hook those positive to negative, and you could get 48 with the 6 volt. But more common is the 24 volt system. There's a good reason, like say the batteries are grouped better. Not only that, but you can buy 24 volt solar panels. All of a sudden, if you're going 12 volt, you should buy 12 volt panels, 12 volt batteries, and you line that stuff up. If you're going to buy a 24 volt system and use the 6 volt battery, you can balance those numbers. They go together better. You have fewer problems. When you go to 48, what you find is that some of the charge controllers, now the Outback, the $500 charge controller that we talked about a while ago, that will handle up to 9 panels, 10 panels. That one operates at 150 volts. Okay, and so you have the 24 volt panels, and you're operating a 150 volt charge controller, which in turn is charging a 48 volt battery bank. Now we're at DC at those voltages. Now we go to an inverter that's going to a 120 or 240 or 308 output on the AC side. So it sounds complicated. It isn't. It's really easy. It's really simple. The solar panels, let's see, I have here.
How many panels do they have at that lodge you're talking about for the 600 batteries?
They have some pretty high, for one thing, to keep the panels down, so the panel count seems low. is they do have a tracking system, a single axis tracking system on it. That increases the output of the panels by 30 additional percent. A dual axis tracker will improve the output of a panel by 60%. For a long time, people were switching away from tracking, but the cost of tracking has come down. You'll see what they're using now is just a gate opener like you have on your electric gate at your house. And they have a sundial that actually is in a mason jar that tracks the sun that bolts to the panel. And it makes an adjustment to the panel every 2 seconds. And it can be dual axis. They do have dual axis, but most people are just putting the single axis because, well, if you have your winter and summertime, you can tip your panel towards the sun in the morning, and the garage door opener through the day pulls it back this direction. Then when the sun comes back, it goes right back and it tracks it. And that will pull 30% more. Then you add an MPPT in there. Those are worth investing in, the MPT for sure. You got 60% more out of a panel by setting it up if the cost is right. With theirs, they had 1,240 panels. Most of it was because they had huge daytime demands. They were running some big 500 and 600 volt DC motors that were operating heavy irrigation wells and things like that on the property for 30 or 40 acres of lawn that they maintain there. So let's talk about the panels again. Each panel is 24 volt. Okay. The charge controller is 150 volt. If you're going to build a bigger system, this is the Outback. This is the $500+ one. Okay. What you're going to do is you're going to do the same thing you do with the batteries. Okay. Just because the charge controller says that it operates at 150 volts, you can't take it all the way up to the limits. Okay. Those limits are there for protection because in, say, a solar panel is made out of silicone, which is a semiconductor. The colder a semiconductor gets, the better it conducts electricity. Then you add a minus 30-degree day with snow cover and full sun, and all of a sudden, what 3 times 24 is 76 volts. That's all you can put on there because when you get those cold temperatures and that high exposure to sun, all of a sudden you're up at 190 to 180 volts. It'll fry the charge controller. So this calculation is really critical. When you buy the solar panels, if you buy your solar panels and your charge controller from Amazon, nobody's going to be there to ask the question, how many solar panels of this brand can I put on this charge controller in a group? Okay. And if you call like Wholesale Solar or GoGreenSolar.com, some of the better solar manufacturers, they will tell you this panel, put 3 of these or put 4 of these, and that'll be the maximum you can get. Well, how do you get to 9? So we're now at 70 or 40, 60. Actually, when you get them operating at full voltage, let me write down what I see on the numbers on my meters all the time. These true panels with positive to negative are going to run 108 volts. Oops. In full sun on a good day, that's about where they're going to average in if you look at the charge controller. So I've got 108 volts and I have 60 amps to carry. So I've stacked up my volts. Remember when I connected those parallel on a 12 volt battery, the amperage went up. When I connected them in series, the voltage went up. So if I connected these in series, I'm now operating at 108 volts. but my amperage didn't go up. This is a 16 amp panel. I have 60 amps worth of space on the charge controller. So what you end up doing is you do one group of 3 connected to another group of 3. These are coming in parallel. And then you can have another group of 3 hook in. Those wires get tied, all the pluses and the minuses. The pluses all get tied together and the minuses all get tied together. So I have 3 groups of 108. I have 16 amps on the total. And I have to have room for those cold, bright days because you'll get voltage spikes in them and you have to protect your equipment from it. Okay? Anybody have any questions? I can make a 12 volt panel come out to 150 volt operating tube. It's connecting series and parallel connections on that. Those are real simple to look up. I can draw pictures and do all that, but it's better if you just open your little secret cell phone and tell Scotty to beam you down the picture of a series or parallel connected group of 3 solar panels or a series 48 volt bank of batteries, because it's good to have that information, and it's easy to get. You can just click on images of battery banks, and there are hundreds that people have already drawn right there that are really easy to understand. You just have to make sure and mark your connections so you know which ones are hot and which ones are neutral. And everything else has pluses and minuses on it when you go together. So, I mean, if people are afraid to hook it up, and you have somebody that's an electrician, a lot of times they can do the AC stuff, but then it comes to the battery and they start scratching their head because they never hook AC in series. It's always hooked parallel. So there are people that have no problem with it, but it's pretty easy to find. Just open on the cell phone, put a 48 volt battery bank, and with 12 volt batteries or with 6 volt batteries, and you'll get a really nice diagram. Or you can go to Google and Google it, and you'll get a good picture of it. When you come to hooking up these, it's the same thing. There are so many resources now. You just click on an image and type in 108 volts, 3 panels, you'll put something in there, you'll find a picture of what you're trying to do. If you have any problems, I don't have any trouble. If you guys call me, a lot of times I'll click on the phone and I'll suggest a specific picture, or we can talk it over. I like to help. People call me all the time with little troubleshooting questions on stuff. It's fun to be able to try to pick those things apart and get them working again when they're out there. So next time we're going to go over sizing inverters.
Does the wire change every time you go up on the numbers?
Okay, so all of your wires are going to have to be calculated by somebody that knows how to calculate wire. Or you can open up an app by Southwire. But if you don't put the right numbers in the right boxes, you're not going to get the right size wire. That's really dangerous. If you try to run a house on an extension cord, the extension cord eventually is going to catch fire as you turn more things on. There's no ifs, ands, or buts about it. When it reaches its limit, it melts. And so, just like anything else, if you don't know how to do the wire calculation, ask somebody. There again, I do that all the time. People will call me. I'll run the numbers on my software and I can give them the type and wire and everything. It takes a minute and a half, 2 minutes for me to run the numbers on it. But you have to make sure that the wire is also for the purpose that you're going to use it for. For instance, if you're going to leave it out there in the sun laying in the water, it's got to be rated to do that. If it's going to be out there in the sun, it's got to be rated for sun, because if the jacket wears off and you have exposed wire, it's definitely a safety risk. With solar, more and more I put everything into conduit. Nothing. Once it gets to the rack, it's in conduit. Once it exits the building, it's in conduit. It's just too easy for somebody to grab hold of a wire and pull a hot wire loose. And batteries are always hot. I mean, if you grab the wrong set of wires, I've never been shocked by a DC battery, but I have been burned by DC electricity. And the burn is easier to get burned by DC than it is to get shocked by it. But either way, it only takes 7 amps to kill you. That's pretty small.
Do you ever work with any monitoring systems or software for
Sure.
different PCs?
If you're going to go with Outback, I mean, Outback has the great systems. They'll give me 300 days worth of data on the Mate 3 right now. I can, if it has internet service, I can log into somebody's Mate, and I can, if they can say, well, this isn't working, I can see the exact data. I can see what the panels were operating at in 15-minute intervals all day long. It's all on an Excel sheet, spread really nicely. I can see what the low voltage of the day was, at what time of the day it was. I can see what the panels were producing in a view of a graph. I can look at it on a table. I mean, there's so many ways to look at it. So I can look at the performance definitely of Outback. It's about a $700 monitor for an off-grid system, but it gives you too much data sometimes.
And for the owners of the system, is there software or systems that would allow them to track what their source power is versus how they're using it?
Yeah, I mean, the Mate does that. It's tied to everything. The grid-tied systems are a little different. There's lots of different monitoring. A lot of them, now you can access them on your cell phone. You can access them on your home computer. They have screens right on the monitor. You know, when I try to access, I usually pull it up in the Excel spreadsheet form because I'm able to examine the data in different ways and interpret. I can do a query of certain data and pull all of that out. Funny story, I put in a solar unit pretty big for a ranch, and we went really well all summer. They never heard from them. They were happy campers. Hunting season opened up. The system started shutting off on me. So the third night that the hunters were there, they called me, the system's down. So I go back up there, show them how to auto start the generator, because you know these people are coming from out of state and they're staying in a nice rental deal. Went through this for a couple of months, could not figure out why the system keeps shutting down. Why is this thing running out of juice? And finally, the Zuni kid tells me, it's because they're charging electric hunting vehicles. So, I mean, you have to watch your loads. And I kept looking at the data. How am I taking more energy out during the day? They have 20 LED bulbs in here in the refrigerator. They have enough power to run. You know, I'm thinking, what's going on? I'm driving myself nuts. And I mean, I never looked at the front of the hunting vehicles, those EVs, like the 4-wheel drive ones that are all, but they actually had yellow electric plugs embossed on the hood where the charging ports were, and they were always parked right next to the solar unit. So and the lithium-ion batteries in those two electric vehicles were 4 times larger than the battery bank on the house. So they could suck it dry pretty quick.
Damn hunters.
Hey, look, they spend $15,000 to have this ranch for 1 week to themselves. So, I mean, that's a lot of money going on to our local economy. It goes into, the guy's not, I've done one for Rico's too, but
Well, I'd say the
This
ranch
guy-
owner
this guy-
ranch owner has to upgrade their system dramatically if they're going to accommodate those vehicles.
Actually, what we did was we just added a bigger generator to it and told them that if you're going to charge, you have to bring your own gasoline, and you can fill up the generator, start the generator, and charge your buggies up. If there's, because a lot of days there is extra energy, so if they look at it and it's like noon and the batteries are full, I mean, put one charger on low, because low was what half of his solar panels were able to produce. So if his refrigerator started, they were draining the battery, but if they were just charging the carts, they could charge one cart at a time and not draw too much power. There's still power going in to charge a battery. So it was a fun thing. It was like an aha moment after you've been out to someplace 9 times, checked wiring. I mean, I literally rewired the system one time. I went through wire by wire and checked polarity. I took and made me a long jumper all the way out to the end to see if I had a cable confused to clear back at the array. Everything was wall to wall, 100%. And that I would get home and they would call me, "It's down."
Eddie, it reminds me in some ways of the culture shock that happened when people first started getting microwaves and other high electric usage
Yeah.
devices in these old homes where the fuses were going out every time they turned on the microwave and they happened to run a fan or something else.
Oh yeah, it's and there's a lot of fires. I mean, caused by 1200 watt microwaves, which are about 15 amps, and that's the maximum for a lighting circuit. So a lot of breakers are 15 amps, and then somebody decides to splice in a plug through what's a electrical line for the lights, and they put a microwave that's drawing 15 amps and they turn that on. You can fry the wire. I mean, there's been plenty of fires that have been caused by microwaves being too big for the wire that it's being plugged into. The new code requires that a microwave is connected to its own breaker at 20 amps. The plug only has one circular plug on it, so you can't plug anything in. It has to be a dedicated circuit now for your microwave, because they're getting so big that they're worrying that it's causing fires. That's why it's in the code book, that it's one circular single plug to a dedicated breaker in the box. Only that can be hooked to the breaker.
And is that for everything, solar systems and traditional AC wiring?
No, I'm just saying for a microwave wire now.
Yeah.
In a new house, it has its own wire and its own breaker.
Refrigerators do too, maybe
Yeah.
for the same reason, but
See,
if you're hooking up a solar, it's a good idea to have your fridge on a separate circuit, but there's no requirement for that yet, is there?
no, that's just kind of like good judgment. Okay, because what happens is, say somebody plugs in a defaulted curling iron and it trips the breaker, and then you don't realize that it was your freezer that just tripped or your refrigerator that just tripped until 4 or 5 days later you go out to get your steaks out of your freezer and you gotta throw the freezer away. I mean, that happens more than you guys think. That. So it is good to have your freezer and your refrigerator on a dedicated circuit, because if it goes bad, it was the refrigerator's fault. If something else happens on a string of plugs, then you don't know if, for a few days. Sometimes they're hooked, I've seen them hooked on, piggybacked on a GFI. They'll plug it in, it'll trip the GFI. They don't realize that the refrigerator just got tripped. I mean, it's always good to have your refrigerator on a dedicated circuit. And for off-grid solar, I've come to the realization that, if somebody wants a refrigerator, just build them a system for an independent refrigerator and don't put another plug on it, because then the kids don't plug in the Xbox, nobody's watching TV. The refrigerator always running, and that's really important to have the food code.
When you're evaluating the installation, you also have to consider what they're planning to use, and isn't the general advice consider downsizing some things? Like, do you need a big refrigerator when a small cooler might be enough?
So I think that if you're really getting down to the green grass, that you'll find people are using the freezers as refrigerators, and what you do is you buy a thermostat kit for it, and at that point it works at refrigeration temperatures on a chest type freezer. Because every time you open the chest type freezer, the cold air stays in the bottom. And so people tend to have them open less because you got to hold them open. And so you grab what you need. And so you don't leave your refrigerator open, walk over and cook breakfast, and then come back and start putting your stuff away. You pick it up, you get your stuff out, you're holding it with your head. The door goes back closed, you haven't lost much cold air. So, I mean, there's some purposes there. The refrigerators that just buy the Energy Star. You buy fewer panels, you buy fewer batteries, you just save money on, you got a nicer fridge and you save money on your solar. Believe me, you saved a lot of money. It's better not to have to make the electricity than, to try to save money by using an old refrigerator. Old TVs use 5 times more electricity than an LED TV does now. And, it was like amazing. People were saying, we're saving all this electricity, we're dropping our electric costs. And it took them a while to realize it's all those LED TVs going out of Walmart. Everybody wants a flat screen. They just like the flat screen because it's flat and it has a better picture. They don't realize they're using 5 times less electricity. It's just happening. It wasn't like anybody wanted it to happen. It just was because it was. The LED light bulbs, they're down to $2 each. You see them in bundles all the time. And the amount of electricity when people screw those in, 5 times less electricity. And if you have like a bulb in your living room that's on all the time and it doesn't have an LED bulb in it, I've got the psychiatrist for you. She might be able to walk you up even. Because let's face it, I mean, the bulbs last longer, they save you money. The light is better out of an LED. Everybody, I get more and more of that when we change out LED bulbs in businesses, because the new tubes that we're installing, all we do is cut the ballast completely out, tie the hots together, and they're neutral. One side of the fixture is hot, one side of the fixture is neutral, and we drop the bulb back in. And the bulbs, the bright ones have 2 rows of LEDs that we're putting in the 8-foot tubes. So what happens is, now instead of having to replace 2 bulbs, we actually only have to replace 1 bulb because it's as bright as the 2 bulbs were. But more than that, the employees and the businesses have said, it's so much brighter in here. My eyes, I'm not as tired, and it's just more cheery, it's brighter. It's just better light. And I've had people say, oh, but the LEDs give me a headache. Oh, the compact fluorescents are what gives you the headache. Those things flash at 60 times a second. And a LED, I think we learned from your son, was up to 1,500 times a second. Yeah. So your nephew, I mean, that was a revelation to me, because it was using a pulse width modulator to pulse the light, and they could alter the wavelength and make the colors different by changing the pulses. But I mean, it's pulsing at 1,000 times per second, and so your eye can see 1/20th of a second. I think the motion of a propeller starts looking like it's moving backwards once it exceeds a certain revolution. Same thing. I mean, the compact fluorescents, they do, people have complained that have migraines, that those will trigger migraines, but I have people say, oh, the LEDs. No, it's not the LEDs. It's not the curly Q ones that give you headaches. And LEDs save you so much money on your solar. If I was to have a 100-watt panel that I could buy on Amazon for $125, one 12-volt battery, and $80 charge controller. I could run 3 good-sized LED lights and never turn them off, and they would probably never run out of energy. So if you just wanted, had a Hogan and you want a couple lights, all you need is that cheap charge controller, a single 100-watt panel, and a battery. And you don't need an inverter. Why? Because you can buy all of this LED lights in DC in 12 volt. It's easy to install. Everybody's hooked up the batteries on their car. They only have a plus and a minus. It's hard to get shocked by DC. So, if you just have a place and you just want lights only, and if you want just lights and TV, you can do that, because Walmart has a DC 12 volt battery, or 12 volt 24-inch LED that runs on 40 watts an hour now. And that's nothing. And it actually, I think it said it even had a DVD player built into it, and it operates at 40 watts. So the thing that you do have to watch is the brightness on the screen. So they cheat that number. You can not have it so bright and bring it down to 40, but if you run it all the way up, you're probably running about 60 watts on it. So the brighter the screen, the more watts it's going to use. Any other questions?
Wow. That's a lot to learn.
Yes.
It's good. Were you going to give us homework for next time about sizing systems?
Okay, anybody that's interested, next time I'll size your inverters for you. What I need is a list of the electrical appliances that you're going to operate. So if you live in a trailer and you need to tell me I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lights in my house, okay? And one of them, you're going to say that it's on 10 hours a day, but some of them only get turned on once a week. The ones that weren't turned on once a week, they really don't matter. Unless you walk in and turn your closet light on, close your door and walk away, and then you come home and your battery's dead. It mattered. So, yeah. If you're gonna run a washing machine off of it and a dryer, then I need to know how many loads of wash you're gonna run, wash and dry. And if you're gonna run an electric dryer, it's not feasible to do it from solar. Use a propane dryer. Better yet, use clothesline. It'll save you more solar panels than both of them. The other critical load is if you're going to have a refrigerator and a full-size freezer, I need to know, that you're going to have both. A refrigerator, one of the bigger panels, the 250-watt panels, that almost makes enough electricity every day to run that electricity, just one solar panel. And one battery almost has enough storage in it to run that refrigerator for one day. So you could do it with that little square charge controller this one runs a 24-volt panel that charges a 12-volt bank. So you could almost do it. The thing is almost doesn't cut it when your freezer thaws out. So you need to back it up. I always say two panels will give you a little bit of lights in your kitchen, and it'll keep your refrigerator running. Okay, so I have people that are running on 4 panels. They have refrigerators, LED lights, LED TV. They're watching Dish Network, but they have a strategy for living. They say, okay, it's like having any other budget. I only have so many watts I can use on TV every day. I only have so many watts I can use for doing laundry every day. Okay, if you had a cloudy day and you start doing laundry at night, you're draining your battery down. If you have a sunny day and your battery's almost full or is full and you start doing laundry, you're probably running off the sun, and it has nothing to do with your batteries, because the sun's making enough electricity to run your refrigerator and your washing machine and your dryer. So you haven't created a deficit. So you do have to watch it. The strategy I'm talking about, don't do washing and drying on days that it's not sunny. Don't watch 10 hours of TV when you only had 3 good hours of sun that day. You know, learn to manage the amount of electricity. That's what's good about having the metering on your charge controller, having that information there, because when you get home, you can say, I only have half a battery, so you kids turn off the TV. Okay. And that's the big complaint. I mean, I have ladies that have bought other panels, and later she says, sometimes I want to shoot the Xbox. You come home and we don't have any light. They watch TV all day.
We hear a lot about the vampire power, that having things plugged in that you don't really have to have plugged in.
Right.
That becomes more important in a solar situation, I would think.
It does, but now it's becoming less of an issue because the vampire they've got them down to where they idle themselves down pretty hard now. So it's not like when we used to leave our VCR on to record something, it was pulling quite a pretty good load of power just in standby mode. But some of the stuff will drop down, some of it won't. I mean, it's always good to. The thing is, if you turn your dish network off, then you go to watch TV, you gotta wait 20 minutes for it to cycle through all the craziness before you can watch TV. So do you turn your dish network off? I mean, that's a calculation you have to make yourself. Cell phones and battery backed up laptops, they use so little electricity that they're hardly, unless you have 20 laptops, we don't even figure that into the calculation because they're just small amount. A cell phone battery only holds 9 watts. I mean, it takes a long time to put 9 watts in there, but that's all it holds.
Thank you.
I was just carrying in some display material which I set up here, and a guy came up to me and outside on the street and said, I'm just building a cabin and I want to put solar in. And I said, well, come in. And he said, I couldn't make it tonight. I'm coming back next week. I said, come back with your design, your song. I got a guy here that'll help you. So hope you come back next week.
I will next week. Right.
Thank you, Ed.
So the UNM branch in Gallup had a plasma cam. Does anybody know anything about plasma cam? So it's a robotic plasma cutter that you can program to cut anything you want. Elk, deer, parts for cars, brackets for buildings, whatever you need, cut any piece of metal from 20 gauge all the way up to 2 inches thick, it'll cut. It sat there for 2 years, nobody knew how to hook it up. And somehow Chris told somebody, you ought to have Ed look at it. So I spent about a week over there playing with it, and we have about 12 students that are cutting pretty much anything they want out of it already. They've learned how to program, taught them to program the CAD system. It's all, if you can draw with AutoCAD, you can import your drawings, you can trace all that stuff out, so you can make any part you want from AutoCAD, from an AutoCAD drawing.
Is it like a CNC system?
It is a CNC system, but it has a plasma cutter, or it has a router in it that will mill aluminum, brass, or wood. So it does 3-dimensional carvings also. So I'm teaching that now at UNM. And so they also have one at the Valencia location in Albuquerque. So been lots of fun, cutting all kinds of crazy things.
Where's it located at?
It's in the welding shop at UNM. At both locations have welding training.
If I understand this correctly, it's a non-mechanical system, so there are no parts that wear down?
Oh no, it has stepper motors, it has gears, it has...
But the cutting surface itself isn't going to wear down?
No, the nozzles will wear out eventually because when it blasts the plasma, because it's plasma that's arcing between the plate and the... it's pushing quite a bit of air or carbon dioxide depending on what you're running, what type of material cutting, and it actually swirls like a vortex of a tornado or a whirlwind, but it's a micro, so small. But the tips wear out because the swirling of the gases. So what happens is pretty soon the kerf starts getting wider and wider. So then to cut the really fine cuts, the metal stuff, that's almost a pinhole going through there. I've noticed after maybe 500 or 600, 700 inches of cutting that we have to change the nozzles out because they're starting to get oval shaped and we're getting a wider kerf than we initially planned. But they're talking now about adding CNC milling and lathe to the program already because, the kids the students just swarm me when they see me, the first time I do a cut. We did a horse, we cut out a big horse, and we did a bunch of stuff for the hospital. And they were like, how come this machine's sitting here? How come nobody's teaching us how to use this? We want to know how to use robotics. So, I think that's going to be a lot of fun. We're setting up to do some solar training, possibly in UNM location in the Rio West Mall. And so we'll have a couple of Saturday classes where we'll have inverters, charge controllers, solar panels. People can sit there and coming through and they can just plug them in because technically if you set it all up right, you can set these things up to just plug in. So, they'll be able to see the plugs, they'll be able to unlock them. They'll understand that it's just a couple of wires. If you're dealing with 12 volt, it's really simple. 48 volts, not that bad. I know some of you guys are really interested in putting your house on it. Just go 48 from the start. Your batteries are gonna last longer, you're gonna use smaller wire. The it's easier on the equipment. When you're pushing 2,000 watts out of a 12 volt system, you're pushing the system pretty hard. When you're pushing 2,000 watts out of a 48 volt system, it's 4 times cooler that it's running. It's just like running that little piece of air conditioner tubing and trying to fill a barrel of water versus having a 4-inch pipe and turning it on. That's the difference. And you have to have the pressure up so high on the 12. The amperage goes way up and the voltage stays the same. The wire overheats at that point.
Does everybody have the power estimator that he was talking about where you calculate your wattage and so on? You guys try to grab the table.
Thank you.
Thank you.